Welcome to the last module of LISP your mesh to shape, which will try to show now how our shaped up meshes can be transformed to surface and solids with the added edition possibilities that this implies. Our meshes can be edited interactively with a series of commands available in the Mesh tab. You should explore them on your own. And you can also convert them to surfaces and to solids for further processing. The surface or solid resulting from the conversion is influenced by the Smooth Mesh Convert variable setting. These settings are also available from the Convert Mesh panel of the Mesh tab. In many cases, the surfaces we shape up are to be used as laminar structures. So they will be slabs with a certain thickness. This is readily available as one of the solid edition options. The thickness option will take a surface object and transform it into a 3D solid with the thickness specified by the user. In case the object is not a surface, the thickness option will offer the possibility of transforming it to one. Surface equations are always referenced to the coordinate system's origin. We can achieve a series of complex forms by changing the mesh object's position or rotating it. In the screen capture we are showing, the mesh is moved and the shaping command reapplied. Once we have achieved the desired shape, it will be smoothed and the thicken command used to transform it into a 3D solid. This will be our last transformation before we apply the thicken command to turn this into a slab. We'll soften it a bit through smoothing, and then apply the desired thickness. In this case, we will explore the effect that can be attained by applying successive transformations to a mesh which is rotated, in this case a 45-degree rotation. The mesh is softened to level 4, and after the first two transformations, a new one is applied to obtain a vault-like structure. This structure again is transformed into a solid using the thicken command. We have been using flat meshes, but very interesting shapes can be obtained when the initial mesh object is one of the mesh primitives. In this case, we will explore a sphere's transformations. We apply first a transformation on the z-axis direction. You see the mesh must be smooth to close some gaps. Then a transformation on the y direction is applied to arrive to the final shape. In this last exercise, we'll be using a drawing with two solid cubes in layers surface 1 and surface 2 and a flat mesh on the xy plane. We will apply to it an initial transformation using equation S09 in the z direction. The transformed mesh will then be mirrored about the xy plane using the Mirror 3D command. To avoid confusion, we will change one mesh to the surface 1 layer and the other one to the surface 2 layer. We will then subject both layers to a new transformation in the z direction, this time using the S04 equation function. Here we have the first one, and now for the second one. We'll now be working in the surface 1 and surface 2 layers in order to slice our solids using the transformed meshes. Of course, we will have to convert them into surface objects to use them in the slice command. We will use the slide command's surface option and in this case choose to keep the upper portion of the solid. We'll now do the same in the other surface layer, this time keeping the lower portion of the solid. We now have two solids in which some portions overlap. The shape I am looking for is the one defined by this overlapping. To keep only that portion of both the upper and lower solids, I can use the intersect command available in the Solid tab's Boolean panel. After a while, we'll be left with the surfaces and the intersection solid. Let's change the solid to a different layer so we can turn off the surfaces. And this is what we get. Let's call the cmd-sw function to apply our programmed point of view and visual style. And to wrap this up, let's see the simplest way we can use any of these shapes in Revit. You'll find a lot of classes in AU 2012 by real Revit experts, which I'm not. So be sure you don't miss them. This concludes our last module and our class. I hope it has lived up to your expectations. If so, I would be glad to hear from you and if necessary answer any question you may have. I'm usually around some of the social networks like Facebook and LinkedIn, and I also have my own website. And of course, you can also contact me through the Autodesk Educational Community Network. If you enjoyed my class, I'm sure you will also enjoy reading my latest book, which you can find at Amazon. And be sure to follow the many classes hosted by AU 2012.